For nearly a century, the story of how humans first reached the Americas had one fixed date: 13,000 years ago. That was when the ice melted enough to open a corridor, when the first hunters walked south from Alaska, when the Clovis spear points appeared across the continent. It was settled science. Then, in the gypsum dunes of southern New Mexico, something appeared that should not exist. Human footprints, pressed into ancient mud, dated to 23,000 years ago, at the height of the Ice Age, when towering glaciers supposedly sealed every route into the continent. Skeptics attacked the methods. 3 separate research teams answered with 3 different dating techniques. All of them arrived at the same impossible conclusion. This is the story of how footprints buried under the world's largest gypsum dune field are rewriting the earliest chapter of American history. In 2005, David Bustos arrived at White Sands National Park to work as a wildlife biologist. The landscape was surreal, endless waves of pale gypsum stretching toward distant mountains, remnants of an ancient sea that evaporated millions of years ago. But Bustos was not looking at the dunes. He was watching the ground after rare storms, when moisture darkened the surface and strange shapes emerged. Animal tracks. Enormous ones. They would appear for hours, then vanish as the sun dried the sediment. Local accounts mention similar sightings as far back as 1932, when a government trapper named Ellis Wright reported footprints 22 inches long. He thought he had found Bigfoot. What he had actually found were the tracks of Harlan's ground sloth, a creature that went extinct more than 10,000 years ago. By 2009, Bustos had identified something else among the animal prints. Smaller impressions with clear heel marks, medial arches, and individual toe pads. Human footprints. But when he showed them to colleagues, the response was dismissive. Slipping camels, they told him. Optical illusions and shifting sediment. For years, the tracks remained unconfirmed. This was the inheritance of Clovis first, a theory so dominant it shaped what researchers were willing to see. The Clovis culture was named for a site near Clovis, New Mexico, where distinctive fluted spear points were found alongside mammoth remains in the 1930s. These tools were dated to roughly 13,000 years ago, and for decades, they were considered the oldest evidence of humans in the Americas. The theory proposed that people crossed from Asia on a land bridge, then migrated south through a corridor that opened between 2 massive ice sheets, the Laurentian in the east, the Cordilleran in the west. When that corridor opened, humans poured through. Before it opened, no one could have arrived. The logic seemed airtight. The ice sheets during the Last Glacial Maximum, roughly 26,000 to 19,000 years ago, were immense. The Laurentian alone covered most of Canada and stretched as far south as Missouri, reaching thicknesses of nearly 4 kilometers. Its western edge merged with the Cordilleran ice sheet along the Rocky Mountains. Together they formed an impenetrable wall from the Arctic to the mid-continent. No corridor existed. No passage was possible. Except the footprints at White Sands were sitting right in the middle of that supposedly impossible window. In 2017, Matthew Bennett, a fossil footprint specialist from Bournemouth University in England, visited White Sands at Bustos' invitation. What he found stunned him. Not just human tracks, but thousands of prints from extinct megafauna, Columbian mammoths, giant ground sloths, dire wolves, ancient camels. And crucially, the human and animal prints were interlayered. In some places, human footprints stepped directly into mammoth tracks. In others, sloth prints crossed human trails while the mud was still wet. These weren't separate events separated by millennium. They were moments frozen within hours of each other. Bennett brought in a multidisciplinary team: geologists, dating specialists, geophysicists. They began systematic excavations, carefully trenching through the sediment to expose layer after layer of buried tracks. What emerged was extraordinary: 8 separate horizons of human footprints, representing at least 16 individuals, most of them teenagers and children. The tracks told stories, a mother walking with a toddler on her hip. The child's prints appearing, disappearing, reappearing as she set it down and picked it back up. A group stalking a ground sloth. The animal's tracks showed it stood on its hind legs and spun around, perhaps catching their scent, before dropping to all fours and fleeing. But the key discovery was the seeds. Embedded within the sediment layers, directly associated with the footprints, were seeds from an aquatic plant called Ruppia serosa, spiral ditchgrass that once grew along the margins of ancient Lake Otero, a body of water covering more than 4,000 square kilometers of the Tularosa Basin during wetter climates. The seeds provided organic material for radiocarbon dating. In 2021, Jeffrey Pagati and Kathleen Springer of the U.S. Geological Survey published the results. The footprints were between 21,000 and 23,000 years old. The scientific community erupted. The dates placed humans in New Mexico during the Last Glacial Maximum, when every migration route was supposedly blocked. Critics immediately attacked the methodology. Ruppia serosa is an aquatic plant. It absorbs carbon from the water it grows in, not from the atmosphere. If that water contained ancient dissolved carbon, what geologists call the hard water effect, the seeds could appear thousands of years older than they actually were. The challenge was legitimate. Aquatic plants are notoriously unreliable for radiocarbon dating precisely because of reservoir effects. Skeptics propose that the real age of the footprints might be closer to 15,000 years, still old, but within the accepted window for human arrival. Pagati and Springer had anticipated this criticism. In 2023, they returned to White Sands with two new approaches. First, they collected conifer pollen from the same sediment layers, pine pollen, from terrestrial trees that pulled their carbon directly from the atmosphere. No reservoir effect possible. Second, they extracted quartz grains from a clay layer directly above the oldest tracks and used optically stimulated luminescence dating, which measures when mineral grains were last exposed to sunlight. The pollen returned ages between 23,000 and 21,000 years. The OSL results showed the quartz was buried between 21,400 and 18,000 years ago. Both methods confirmed the original seed dates. Still, some researchers remained unconvinced. In 2024, critics published papers arguing that even the pollen could represent maximum limiting ages, that the grains might have been reworked from older sediments. The debate continued. Then came the 2025 study. Vance Holliday, a geologist and archaeologist at the University of Arizona who had worked at White Sands since 2012, led a new team back to the site in 2022 and 2023. They dug fresh trenches, exposing additional geology. This time, they focused on something no one had dated before: the ancient mud itself. Lake Otero had been surrounded by marshlands, and the organic-rich sediment from those wetlands was still preserved beneath the gypsum dunes. Holliday's team extracted samples of this mud and sent them to two independent laboratories for radiocarbon analysis. The results: 20,700 to 22,400 years old. 3 different materials, 3 different research teams, multiple independent laboratories, 55 total radiocarbon dates, all converging on the same conclusion. You get to the point where it's really hard to explain all this away, Holliday said. It would be serendipity in the extreme to have all these dates giving you a consistent picture that's in error. The footprints are real. Their age is confirmed, and the implications are transforming everything researchers thought they knew about the first Americans. If humans were in New Mexico 23,000 years ago, they arrived before the Last Glacial Maximum sealed the interior routes. That means they either came earlier than previously imagined, before the ice sheets fully merged, or they took a different path entirely. The most likely alternative is coastal migration, small groups moving south along the Pacific coast by boat, island hopping and beachcombing along shorelines that are now submerged under rising seas. The ice-free corridor itself has fallen under scrutiny. Recent studies suggest it wasn't biologically viable, capable of supporting human travelers with food and water until approximately 13,800 years ago, too late to explain pre-Clovis sites. The corridor may never have been the primary route at all. What the footprints reveal is equally striking. These weren't isolated hunters passing through. Families lived here. Children played in the mud between mammoth prints. People tracked giant sloths and watched them rear up in alarm. For at least 2,000 years, according to the 7 soil layers containing tracks, humans occupied this landscape during the Ice Age. The question that remains unanswered is the one that has haunted the discovery since 2021. Where are the tools? Hunter-gatherer archaeology typically depends on stone implements, fire pits, butchered bones. White Sands has none of these. The gypsum-rich soil dissolves bone. But critics point out that even perishable tools should leave traces, and they haven't appeared. Holiday has an explanation. These people were mobile foragers, far from raw material sources. Stone tools were precious, maintained, and never abandoned. They're not just randomly dropping artifacts, he noted. It's not logical that you're going to see a debris field. The footprints captured people in motion, walking, hunting, carrying children. Moments, not settlements. For now, the debate continues. Some archaeologists want more sites with corroborating evidence before fully accepting the timeline shift. Others argue the convergence of dating methods settles the question. Today, wind erosion continues to expose new trackways at White Sands while destroying others. Park staff estimate the area may contain over 100,000 fossilized prints, but each storm changes what's visible. Teams use ground-penetrating radar and photogrammetry to document tracks before they vanish. They call them ghost tracks because they appear when wet and fade when dry. Echoes of lives that flickered across this landscape and nearly disappeared from history. Kim Charlie, a member of the Pueblo of Acoma who works with the research team, sees something else. These tracks trace back to us, she says, back to the indigenous people of North America. The debate over dates, she notes, doesn't change the connection. The footprints are like photographs, a family preserved in mud, saying we were here. 23,000 years ago, while glaciers locked the continent in ice, someone walked the shores of a vanishing lake in what is now New Mexico. They carried a child. They stalked a giant sloth. They left prints in wet clay that hardened, were buried, and waited. Now those prints have surfaced to overturn a century of assumptions about when the Americas were first inhabited. The evidence is beneath our feet, buried in gypsum, confirmed by seeds, pollen, quartz, and mud. What do you think?